Hello, my name is Chris Peters, and this is a project designed by myself, Alexander Barrow, and Kelvin Jerry for our Advanced Computer Engineering class at Elizabethtown College. For our project, we had to design a digital circuit that would implement a pipeline for fetching, decoding, and executing. We had to create a finite state machine as well, and come up with an opcode that would make the circuit perform a task. The task we decided to give the circuit was calculating velocity given an acceleration, a time, and an initial velocity. First, we'll take a look at the overall circuit. The way the circuit works is data is taken from the registers and then mathematically manipulated with both the up and the down counter. The results are then brought back up and stored once again in the registers for later use. Next, we'll take a look at the opcode. The opcode tells the circuit exactly what to do and when to do it. This allows us to select which register we want to take data from, what we want to manipulate it with, and then where we want to store the results. After this, we'll take a look at the control logic. The control logic interprets the opcode and then tells the program what to do based off of it. Now, let's look at what our circuit is supposed to do. Our circuit is supposed to calculate velocity given an acceleration, a time, and an initial velocity. The first step to our opcode is first taking the value of acceleration from the up counter. Next, the value of initial velocity is taken from the up counter. We can see that the two values that we just took from the up counter have been stored up top in the registers. Next, we receive the time value from the down counter that for this circuit has been turned into an up counter. After all three values have been stored up in the registers, it's now time to do mathematical manipulation of the three values. We start by first multiplying the acceleration by the time. Just like before, the value is then stored up in the registers. After this, initial velocity is added to the results of the previous equation. After this is done, we then have our final answer, which is then stored once again up in the registers and is now displayed on the 4 hex displays on top. Now, we will show how our program works by actually putting numbers in and showing that the correct answer will display on the 4 hex displays on top. For acceleration, we will set the up counter to 2. Then, we will use 5 for the initial velocity. The time element on the down counter will be 3. So, our final value should be 20. As we can see, the value provided is 1A. That in hex is 20. This shows that our digital circuit works. Thank you very much for watching.